All right, for this video we are going over the review questions for the last quiz of the year. I'm just going to go through how to do each one of these and my process. You might have done it differently and that's just fine, but we should come out with the same result. So let's look at the first one. On Jason's first 3 tests, he earned an 81%. On the next 3, he earned a 95%. What decimal number shows Jason's average score on all 6 tests? Well, we can't just average these percentages right here because we have to take into account how many tests he actually earned that score with. So we have 3 tests at an 81%, or I'm going to show it as a decimal since that's our what our answer is supposed to be in. So 0.81 and 3 at 0.95. So go ahead and multiply those out, and 3 of 81% gives me 2.43, and 3 at 95 gives me 2.85. We can now actually add those up. This basically represents all of the points that he got on all of the 6 tests. And so when we add up this 2.85 and 2.43, we end up getting 5.28 that we can now find the average by dividing by those 6 tests that he took. When we divide by 6, we end up seeing that we have 0.88 as the decimal number that shows the average score on all 6 tests, or to make it more relatable, this is 88%. So what is the area of the label that covers the can? So we are basically finding lateral surface area of this cylinder, which means that I don't want the bases, so I don't want to add the areas of the circle, but I want to do the perimeter of the base times the height, which means I am going to do the circumference of the circle, so 6 times pi times diameter, and then multiply by 12, which means that I can multiply the 6 and the 3.14 and 12 all together and get 226.08, and we are in centimeters squared since we're talking about area. Now with the same can, let's find volume, and we need to do now for volume area of the base, so big B times the height. So we find the area of the base by doing pi r squared, in this case pi times 3 squared, and then multiply by the height of 12. So we multiply together 3.14 and 9 and 12, and we get 339.12, and since we're in volume, we have centimeters cubed. Okay, now what is the capacity of the can in milliliters? Well, this is still a measurement of volume. We just want to convert the 339.12 centimeters cubed that we had in our previous example and turn it into milliliters. Well, like we learned in a lesson just recently, we need to use a unit multiplier to change this. And what we've learned is that we have 1 centimeter cubed is equal to 1 milliliter. So I'm just going to use my unit multiplier to say I'm going to put that 1 centimeter cubed on the bottom and 1 milliliter on the top. Gets rid of the centimeters cubed, and really it's just 339.12 milliliters. Okay, what is the volume of the pyramid if we have a height of 8 inches? Well, similar process. I'm going to do area of the base times height, but since it's a pyramid, I need to take 1/3 of the volume to get the correct volume. So I plug everything in. 1/3 times area of the base, so 12 times 12, or 144, times the height of 8. We just need to multiply all this out. 144 times 8, and then divide by 3, or you can do that really in any order you desire. 384, and since we're in volume, inches cubed. Okay, so remember that when you have that pyramid, you do need to take 1/3 of the volume to get the correct volume. Now with the same pyramid, we need to find the slant height. Well, remember, to get a slant height, we're going to take a cross section, and that cross section, if we were to cut right in half, is going to look like a triangle. So this triangle has a base of 12 and a height, just like we saw before, of 8. And from here, we cut it in half and we say, I'm going to use this right half, doesn't matter which half you use, but it is a right triangle that is half of the base, so 6, with a height of 8, and using the Pythagorean theorem, or this is a Pythagorean triple, we can say 6 squared plus 8 squared equals c squared, ends up that c is 10 inches. All right, now with this, using 5 pieces of cloth, Sally built the model of a pyramid. How many square inches is the total surface area of the pyramid? So let's find the total surface area, which means we need to find, in this case, 4 of the same triangles going all the way around, and then the area of the base. So for my surface area, I'm going to say area of the base, so big B, plus, and you can do this lots of different ways. I like to think about it as 4 of those triangles, which is base times height divided by 2, but you can still do that perimeter of the base times height. It's up to you. But we say that the area of the base is 144 from that 12 times 12, plus, well, we have, if we look back over on this side, we have triangles that have a base of 12 right here and a height that is the same as the slant height. So we have 4 of these triangles that have a base of 12, a height of 10, and we divide by 2 since we're working with triangles. Ends up that we get 144 plus 4 times, well, 120 divided by 2, so 60. And so 144 plus 240 gives us 384 square inches. Okay, so in this case, lots of ways to go about it. I like thinking about it as those 4 individual triangles, but you can absolutely do area of the base plus perimeter of the base times the height. But just remember, the height of those triangles is the slant height of the pyramid. Okay, Sally built another pyramid 15 times as large. The surface area of the larger pyramid is how many times as large? Well, with this one, we don't actually need to know what the pyramid looks like. All we need to know is what they give us in the information, that the perimeter scale factor is 15, because that pyramid is 15 times as large. We would be saying 12 times 15, 12 times 15, and so on. Which means I can find the area scale factor, which will give me how many times bigger the surface area is, by doing 15 squared, which gives me 225, which means it's 225 times bigger with that surface area. All right, how long is the curve of the tract from A to B if the segment A to B is 120 feet long? So this is 120. Use 3.1 for pi and express your answer to the nearest whole foot. So in this case, I basically want to know half of the circumference. This is a semicircle from A to B, so I want half of the circumference. So I'm going to do pi times diameter and then divide by 2. And I get 3.14 times my diameter of 120, and then we'll divide that by 2. So let's see what happens here. 3.14 times 120, and then we're going to divide by 2. So we end up getting 376.8 that we divide by 2, and we see that half of the circumference is 188.4, but we round it to the nearest whole foot and say that we have 188 feet. Okay, so exact answer up here, and then rounded answer down below for that whole foot. Okay, 2 robots can create parts in 56 hours. How many robots are needed for the parts to be created in 8 hours? Before we jump into this, what we actually have to realize is that this is inverse variation. As we increase the number of robots, the time it takes to create these parts goes down. So let's set this up as we know it, and we know that inverse variation is y equals k divided by x. We need to find what that constant is, basically telling us for like how many hours per robot, how many robots per hour, things like that for our constant. So we plug in what we know, and we know that 2 robots create parts for 56 hours. Well, if I represent this as x and y, and say we have 2 robots for 56 hours, let's plug that in, and we would say 56 equals k divided by 2? Well, to get k by itself, I'm going to multiply by 2 on each side, and I see that 112 is my constant, which means I actually have an equation once I plug it in to say y equals 112 divided by x. Now that we know a new amount of hours, we want 8 hours here for y. We would say, okay, well then if y is 8, what would x have to be? Well, lots of ways to solve this. I would probably set it up as a proportion and say 112 equals 8x, divide by 8, and we see that x equals, well, go ahead and do that division if you haven't already, and you would see that there are 14 robots that we would need for those 8 hours. So we'd have to increase our number of robots quite a bit to be able to get it down to 8 hours. A $15,000 investment grows in value at a compound rate of 15% per year. What is the value of the investment in 3 years? Now, I understand if you struggled with this one because we actually skipped this investigation. So, but hopefully you were able to kind of logic your way through this. Compound interest, what we are saying here is as we increase each year, we get 15% of that total each year. Which means, okay, after year 1, I have 15,000 plus my 15% of 15,000. What we're really doing here to simplify things is saying I want 115%. If I'm increasing by 15% each year, then I have 115% of the total, or 1.15 of 15,000. Well, that's for year 1, so let's work that out. So this is year 1, and we see that 15,000 times 0.15, oops, sorry, let me try that again. 15,000 times 1.15 gives me that after that first year we have $17,250. Now for year 2, instead of just doing 1.15 times that 15,000 again, I use this total, 17,250. So I'm going to use that 17,250, multiply it by 1.15, and we see that after year 2, we have 19,837.50 cents. Then we do it again, last time for year 3. So 1.15 times 19,837.50 cents will give us at the end of year 3 that they have now $22,813, and rounded to the nearest penny because it's 0.125, we have 13 cents. So compound interest takes the amount from the previous year and adds it on top. Okay, just know that this will not be a quiz question, but I did want you to see this idea before the end of the year. All right, so I'll just finish up this review pretty quick here. We'll get into some easier questions in just a second. So there are 20 markers in a bag, half are red and the other half are black. What is the probability of taking 2 red markers without replacement? Well, for the first draw, I am saying I want a red marker. So out of the 20 markers, 10 of them are red out of the 20. For the second draw, I keep that red marker because it says without replacement. So I now only have 9 red markers out of 19. So we go ahead and I would simplify quite a bit before you multiply out. I would simplify this to 1 and 2, and you would get 9 over 38 as your probability. What is the mass of a 3-liter water bottle in kilograms? Well, we would say I want to convert this 3 liters to kilograms. Well, similar to one above, we see that we have 1 liter is 1 kilogram. So I use my unit multiplier to say 1 liter is 1 kilogram. And the liters cancel out, and we just have 3 kilograms as our answer. All right, the radius of a circle is 12 units. Okay, so from here out is 12. The side length of the square is 6 units. What is the probability of an object falling within the circle and it also landing in the square? Express your answer in terms of pi. Well, for this one, I basically want to find the area of the circle that's my total. And basically with probability, if that's my total, I want to know what's the probability of getting in the square. So I want the area of the square on top. All right, so let's find the area of each of those. And the square is probably easiest to find. Area of the square is 6 by 6, so we get 36, and we're in units squared, divided by the area of the circle. Well, the radius of the circle is 12, so pi r squared would say we have pi times 12 squared, so 144 pi units squared. Well, the units squared actually cancel out with this probability, and I can also simplify the top and the bottom quite a bit. This 36 and this 144 can simplify to 1 over 4, so I get an answer of 1 over 4 pi of my probability. If I were to actually multiply this out, you would see that we would have 4 times 3.14, giving me 1 over 12.56, which means for every 12.56 units squared of area, I have 1 chance of getting in that square. So 1/12 of a probability of also landing the arrow in the square. Next one says we want the perimeter of the rectangle, which means I need to add this, and another one of each of those. So we can add all of this up, and I'm just going to write it out. We have a 6x plus 3 plus a 3x minus 2, and another 6x plus 3, and another 3x minus 2. Combining like terms, I would combine 6x, 3x, 6x, and 3x. Well, that gives me 18x. And then I combine the plus 3 minus 2 plus 3 minus 2 to get plus 2. And you can finish this off by saying we are in units since we care about the perimeter. All right, a rectangle has vertices at 2, 6, 0, 4, 5, 3, and 3, 1. Let me just quickly draw this. And then we can find the area of the rectangle. So we have one at 2, 6, and 0, 4, 3, 1, and lastly 5, 3. So we have this rectangle here, and you'll notice that the side lengths are not easily calculated as far as just counting the squares on my coordinate plane. I need to find the side length of each of these. So let's start with this side length here. And I would find that by basically making a right triangle that's invisible on the outside, but saying that the side length of that is 2, okay, 2 high by 2 across. Well, this is actually just a 45, 45, 90 right triangle, which follows the pattern of 2 root 2. You can also prove that with the Pythagorean theorem and then simplifying your radical. Now we can find my other side length here. Okay, or this one down here. Either way, I'm going to use this lower one since it's a little bit easier to see how big this triangle is. And we see that this triangle is a 3 by 3, which means the side length is 3 root 2, meaning that my rectangle has an area of 3 root 2 times 2 root 2, the side lengths multiplied to each other. We can multiply the 3 and the 2 to get a 6. And then we can also multiply the root 2 and the root 2 to get the square root of 4, which we can simplify to say 6 times 2, which is 12 units squared. All right, solve for x. This is a simple one where we want to subtract 27 from each side and get x squared equals 9. Well, we take the square root of each side, but since this is an equation, we say that we have 2 different possibilities. X could be 3 or -3. Last 3 here very quickly. First thing that I would do in this first one is expand out and get 3x minus 2x and then plus 6 equals 17. Combine your like terms here to get 1x plus 6 equals 17. Subtract 6 on each side and get x is equal to 11. And then solve for x. We actually don't want to solve for x here, we just want to simplify. Okay, what this wants you to do is expand out and say, I want to do rainbows here. and smiley faces. Well, my rainbows, x to x multiplied together is x squared. X to positive 4 is plus 4x. My first smiley face, negative 4 to x, is minus 4x. And then negative 4 to 4 is minus 16. When we combine these like terms, we see that they cancel out, and I just get x squared minus 16 as my answer. And lastly, to simplify this one, I would actually put it in its prime factoration first rather than trying to multiply them together first. So I'd get 3 times 2 times 3 times 2 times 2 times 3. And I would put this under one big radical so I can see how many of each I have. And I have a 2, 2, and a 2, and a 3, 3, and a 3, which means I can circle and pop a pair of 2's and a pair of 3's, which if I have 2 on the inside, I have just 1 on the outside. So I have a 2 times 3 root 2 times 3, because that's what's left in the radical. I can simplify both the inside and the outside by saying we have 6 root 6, and that is my answer. All right, well, I hope that this video helps you study for your quiz, your last one. Please make sure that you know all of these different concepts.